Hello, my loyal subjects, your glorious tyrant, the tyrannical cuber here. And this video is going to be a little introduction to an advanced method, CFOP, otherwise known as Friedrich method. So Friedrich method was named after Jessica Friedrich, the creator of the method. And CFOP is like an abbreviation of the steps. Note, I will be referring to it as CFOP, as will most people. But if you hear Friedrich method, you still should probably know what people are referring to. They're referring to CFOP, which is this. So C stands for cross, which is the first step. And this is going to be a bit different from beginner's method cross. This is a lot more efficient and kind of confusing. Note, this is just an introduction, not a tutorial, so I do not expect you to know what in the world I'm doing. This video and the video that will be right after this, and by right after this I mean like 2 minutes after this, which is going to be about another advanced method, Roux. These two videos aren't going to be like tutorials. These videos are meant to help you decide which advanced method you want to use. So yeah, continuing on, F stands for F2L, which stands for first two layers. This is also going to be a bit different from beginner's method. So what you're going to do is you're going to solve a corner edge pair like this into this slot at the same time. So here we have a great example of this. This is known as an F2L pair when the corner is paired up with the edge. And you can just insert it. And I'm just going to finish this up. So F2L would look a lot like that. Third step is OLL for the O in CFOP. And that stands for orienting last layer. So after this face should all have yellow facing up. Now, that can be done in one algorithm. And OLL has a total of 52 algorithms. I don't know all of them. I know a good amount, probably like half of them. And I mostly use something known as two-look OLL, where instead of using one algorithm to solve it all, you use one algorithm to solve the cross, and then another algorithm to solve the corners. In total, I think that might be around 15 algs. Yeah, I'm still working on full OLL. Been a bit lazy. And last step is PLL, which is permuting last layer, and that basically just moves around the last the corner, these pieces, and solves the cube. I'm fairly certain there are 21 algorithms for PLL. I know all of them, but as a beginner you would learn two-look PLL. So you do an algorithm to solve the corners and then an algorithm to solve the edges. In total, I'm fairly certain that is 6 algorithms. And so now, you get to watch me do CFOP solves for the next I don't know how many minutes, and I will be explaining the pros and cons of CFOP, why I use it, why you should use it, and yeah, and like why I temporarily switched to Roux, another advanced method, which will be out right after this in like 2 minutes, like I said in the beginning. And before you decide on which advanced method to use, I highly recommend watching that video as well. And I'll probably add it to the description shortly. Okay, so let's start with the pros of CFOP. One big pro is that since it is the most popular advanced method, there has been a lot of documentation and discovery involving it, more so than in other methods. In other words, there are a lot of different algorithm sets that are not just the basic OLL and PLL. There's stuff like COLL, which stands for corners and orienting last layer. So it's basically OLL, except it only works when the yellow cross, or whatever top color you have, is already solved. And what it will do is it will solve OLL, and it will also permute corners correctly, and that leads to an easier PLL. Another pro is that it is more similar to beginner's method than any other advanced method, meaning that it'll probably be easier to learn for a beginner transitioning from beginner's method. Another thing is that there are a lot more resources for CFOP. This kind of feeds off of the first pro. So with other advanced methods like Roux, ZZ, Petrus, ZZ and Petrus are trash. Roux is pretty good. As I stated before, I'll be making another video on that. So there's a lot more videos and other stuff involving CFOP. Like if you search up ZZ tutorial, barely anything's going to show up. If you search up Petrus tutorial, probably even less is going to show up. If you search up Roux tutorial, maybe a bit more than ZZ, but not that much more. But if you search up CFOP tutorial, there will be like a mountain of results, which would of course help with learning. Also, it doesn't hurt that every world record set so far is in CFOP. Also, all of the good all the good big cube methods like 4x4, 5x5, 6x6, 7x7, all of them are variations of CFOP. Now, that may not really make much sense to you, but when you learn 4x4, it will definitely make sense. So, Roux, if you learn Roux, you're going to have a really hard time with 5x5. I guess you could still manage in 4x4, but you're going to have a really hard time with 5x5. If you learn CFOP, 5x5, 4x4, and stuff that's bigger than that, will be a whole lot easier than if you learn Roux. So if you're planning on learning how to solve a 5x5, or actually, well, if you want to get really fast in 5x5, don't even bother with watching my Roux video. Just start learning CFOP. Another thing is that CFOP is really algorithmic. In other words, there's a lot of algorithms involved, and it's not really that intuitive. Like, there aren't really that many really, like, clever things you can do to make your solve more efficient. Like, there are, of course, but there aren't that many. Like, there's really only one good way to solve each F2L case or OLL case or something. And this can be considered a pro or a con, depending on who you are. And that leads me to the cons. Firstly, there are a lot of algorithms. Full OLL alone is like 52 algorithms, and full PLL is like 21 algorithms. Adding up, that's like 70 algorithms. That's a lot, and for a beginner, that will seem very daunting. but it's learnable, since mostly because most of the algorithms are like muscle memory for most people, rather than, oh, I have a soon. I have to do R, U, R prime, U, R, U to R prime. No, we don't memorize the moves, we just use muscle memory. We only memorize the moves at the beginning when we're first learning the alg. Another con is that out of all the advanced methods, I'm not sure about Petrus, but out of Roux, CFOP, and ZZ, CFOP is the least efficient, meaning you have to do more moves to solve the cube on average, meaning that if a Roux solver, a ZZ solver, and a CFOP solver were all turning at the exact same speed, the CFOP solver would be the last one to finish. He would be the slowest. While a lot of people argue that sure, CFOP isn't as efficient, the Roux and ZZ, the speed at which you can turn is capped, while with CFOP you can turn a lot faster than if you were using Roux or ZZ. Now, that may be true, it may not be true, but I think it's probably true since, well, ZZ is trash. Roux, the look ahead is harder, since with CFOP, well, like you have a blind spot at the back of the cube, and with Roux, this blind spot isn't really, well, it is solved, but it's solved later on. Like, more of it is solved later on rather than earlier on, if that makes any sense. And as for why I switched to Roux temporarily, it was because, like I mentioned earlier, CFOP wasn't really intuitive. So, in Roux, it looked interesting, it was more efficient, and there's more intuitiveness, there's more, like, little clever things that you can do in the middle, and that you just think of in the middle of a solve. So I went to Roux for a while. It was pretty fun. But the problem is that when I started trying to practice 4x4, I was like, wait a minute, I have to find a Roux variation of this. So I did, and I tried it, and I hated it. And then I was like, if it's this bad for 4x4, it's going to be even worse for 5x5. And I was planning on doing 5x5. I really liked 4x4, and now I really like 5x5. So I switched back to CFOP for the big cubes. And that concludes this video, and I hope you now are more informed about CFOP and will make a educated decision in your advanced method choice. And goodbye.